Okay, the next math board is number 9. So it starts with this graph. It says below is the distance time graph for car 1. Okay, so we know that slope is the rise over the run, and here it is the distance over time. Well, distance over time is equal to the speed. So here the slope is representing the speed. It says that this is for car 1. It says now there is another car 2, that is traveling by the function y equals t. So if t is 1 minute, right, time in minutes, then the y, which is the distance, would be 1 mile. Okay, so for example, what I would suggest is kind of eyeball it on here by putting the graph on there. So at 1 minute, let's see, this is 2.5. So this is 3, which means 2.5 is right here. Okay, so I put a point there roughly. Here is 5. Here is 5 right here. So let's say, right, because a distance of time equaling 5, the distance would also equal 5, right? And right here, a distance of, because this is 3, this is 2.5, the miles would be 2.5, okay? And then at 7.5, this is 7, so 7.5 is roughly right there. I'll eyeball it and go right there. So, and obviously, if the car is not moving, it's not gaining any distance. So it starts in the same place, and it's roughly like that. Okay, so let's answer the questions. What is true about car 1 and car 2? Select all that applies. It says the driver of car 1 might be getting a speeding ticket. I don't know yet. The driver of car 2 might get a speeding ticket. Well, if it's these two cars, for sure car 2 is not going to get a speeding ticket. So that one's definitely false if it's between those two drivers. The two cars are traveling at the same speed. Clearly, they're not traveling at the same speed. So that is also false. And then it says, it is not possible from this information to tell which car is traveling at a greater speed. Yeah, it is. This slope is increasing faster, right? For every additional minute, the distance is increasing more than this distance. So that's not true either. Okay, so this guy, car 2, it is distance equals time. So if he goes for like 60 minutes, then he's gone 60 miles, right? But that's not true with this guy. So what we need to do is figure out what his rate of change is. So this is car 2, and this would be car 1. And we can figure out his slope by saying that the slope is the rise, so that would be 2.5, car M for car 1M. Okay, so a rise of 2.5 over a run of 2 from 0 to 2. So 2.5 divided by 2 would be y equals 1.25 x. So his speed is car 2 is y equals x, right, where the slope is 1. He is going 60 miles per hour. And how I figured that out is in 60 minutes, he goes 60 miles, and 60 minutes is the same as 1 hour. So he's going 60 miles per hour. He is going 1.25 times, so in 60 minutes, he would go, I would multiply it. So in 60 minutes, 1.25 times 60 is going to be 60 plus another 15, because that's 0.25 of 60. So this guy is going 75 miles per hour. So back to this question. We already said that these are false. The driver of car 1 might get a speeding ticket. So I know the answer key, check this for what is true. But you know, hey, what if he's on the freeway? I mean, if he's on the freeway and he's going 75 miles per hour, I suppose if the police officer was being very nitpicky, because a lot of times people go 5 over. Yeah, so if I had to choose one, I'd choose this one. I would say if he's doing 75 down Hall Road, yeah, he's going to get a ticket. If he's doing 75 in like Indiana on I-80, no, he's not going to get a ticket because that's the speed limit. All right, number 2. This graph is for the distance of a car traveling as a function of time. So here's the distance and here's time. So as the minutes start accruing, he's getting further from home. Then there is some point where he has stopped, right? That's what this horizontal line means. That as time goes on, he's not getting further or closer to home. So he has stopped someplace. So he stops for a period, or she stops for a period of time. And then we've got a negative slope, which means the distance between home and where he is starts decreasing. He's heading back home. So let's look at the questions. The horizontal line means the car is moving at a constant speed. No, we just said he's not getting further or closer to home. That means he has stopped. So he's not moving at all. So no, it's not a constant speed. Before the horizontal line, that's this little section, the car was moving away from home at a constant speed. This is a single line to where he stops, meaning it's not looking like this. You know, he went this speed, and then he went this speed, and then he went this speed, and then he went this speed, right? It's very consistent. The whole, from here to here, it's just one slope. So that means, yes, that was at a constant speed. After the horizontal line, the car started heading back home, at a constant speed until it made it back home. Yep, it didn't go like this. Oh, he's going really slow and then really fast. And then, you know, it's not like that. It's just one line connecting from where he stopped to where when he got back home, and it's a consistent rate. So that's yes. The horizontal line means that as time is going by, the car is not moving. That was yes. Last one. This graph was distance time. This is speed time. This graph is the speed of a car as a function of time. The horizontal line means the car is maintaining its speed and it's not accelerating. So from here to here, it is maintaining whatever this speed is. So that's a yes. Before the horizontal line, the car is speeding up or accelerating at a constant rate. So it is a constant rate, right? If I calculated the slope between here and here and here and here, all of these slopes would be the same. And so yes, that is at a constant rate. After the horizontal line, the car started slowing down at a constant rate until it came to a complete stop. So this is a constant rate again. It's one, you know, it's not jaggedy. Well, those wouldn't be nice straight lines, but it's not, it's very consistent. And he does finally come to a stop. So, and it was a negative slope right there, so that means he is slowing down. So that's a yes. The horizontal line means that as time went by, the car was not moving. Well, this is a speed, right? If the car was not moving, it would need to be down here at 0. So the car is definitely still moving. So yes.